Okay, let's start our workshop today. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning and good afternoon from wherever you are. Welcome back again with Saturday for SBE, and this is the second Saturday for SBE. We're gonna have a workshop and a talk, and please stay tuned and enjoy your time with us. I'd like to thank you again for spending some time with us today. Just to remind you, this is Saturday for SPE, organized by Asia Pacific University SPE Student Chapter and Kuala Lumpur Section Young Professional, with collaboration with 9 student chapters from around the world. Okay, just to introduce myself to you, this is Mohammed Al Farsi. I'm an undergraduate student from Sultan Qaboos University. I'm also the president of the QU Student Chapter for the second time in a row, and I will be the moderator for this workshop, inshallah. Okay, all right. Now let's take you through today's agenda. We will take you through firstly with safety moment will be delivered by Mr. Amir, and then membership awareness will be delivered by Ms. Harvin. Then I'll introduce my teammates and the workshop speaker. Then this workshop speaker will take you through what is reservoir simulation, what is computer modeling group, and then we'll take you through broader and a quick demo. Then we will answer your all questions in the chat box, or you can ask the speaker immediately by turning on the microphone. Then we will have a quick Kahoot game, so you can get fun, enjoy our session today. Then we will take a photo for memory. After that, we will have like a quick taking your quick feedback by giving you the link for feedback form. Then we will close our remarks at the end. All right, so HSE safety moment will be delivered by Mr. Amir. So Mr. Amir, the time is yours.
Thank you very much, Fatima, for the kind introduction. Hi, everyone. My name is Amir Lokhanwala, and hello from India to everybody on this call. Let me just begin today's safety moment. Before we begin the meeting, let's take a step back, see the environment we are right now working in. Most of us are working from home in the pandemic, right? So one important issue that we should all speak or know about is ergonomics. So what is ergonomics? It's a combination of two words, two Greek words, ergon and nomoi. So it's the science and art of fitting your work according to the natural laws of the human body. So it's how you can make yourself comfortable in whatever job you're doing. So right now I'm sitting here speaking to you, you are listening to me, right? So what are the things we can do to improve our ergonomics? The first one is your correct posture of the body. So wherever you are, if you're looking at this image, just make sure that you are not in the wrong sitting posture, you're in the correct sitting posture, feeling comfortable, you have your back in correct position, right? So that's one thing. Everybody just take a step back on your posture. Second is the 20-20-20 rule, which is basically, as we are seeing conferences, meetings, etc., for a long period of time, remind yourselves that in every 20 minutes you want to give some comfort to your eyes, look 20 feet away for a period of 20 seconds. So it's just something that will help your eyes adjust to the constant strain that you put yourself in when you have your smartphone, laptop, etc. Okay, so let's keep in mind these two rules as we begin the meeting. And we are in the middle of a pandemic right now, so let's make sure that we remember all the basic steps for precautions against coronavirus. So wear your mask, gloves, wash hands as necessary. Remember one thing as you start this meeting and after you end it is whatever you do in terms of preventive safety right now, as you are after this meeting, within the meeting, is what will allow you to spend time with everybody you love and hold dear to yourself. So let's make sure that we are all following these guidelines And let's go on with the next part of the presentation. I'll hand it back to Fatima. Thanks.
Thank you so much, Mr. Amir, for this good recommendations for safety during working in this pandemic. Now, let's move on with the membership drive. I remember myself last few years, I was asking myself, why do I need to have a membership in SPE? So this is gonna be answered by Ms. Harvin. So Ms. Harvin, the time is yours.
Thank you so much, Fatima. Good morning, good afternoon, good evening, good night to everyone. Wherever you are, I hope you are staying safe. So this is the membership drive presentation. It'll be very short, promise. Okay, next slide, please. All right, so everybody always asks why SPE. So here I am, I'm about to tell you why you should join SPE. Next, please. Okay, so as you know, SPE, we have a lot of events, a lot of activities, a lot of workshops, technical talks, and so on and so forth. So there's a lot of professional benefits that you can actually gather from this, yeah? You can get yourself involved in mentoring programs, ambassador lecturers, distinguished lecturer series. You can even volunteer, such as what everyone currently we are doing. And then you also get to be very visible professionally within your organization as well. You get free education, learning opportunities. You get accredited as a petroleum professional engineer. You can get yourself involved in YP activities, young professional development programs. You can network professionally. This is the main reason why people actually join SPE, is to professionally network with other peers, other colleagues. You can attend trainings, workshops. If you ever stumble upon your career, you can actually get a technical or career advice, community practice, and also you get free access to SPE papers, about 6 annually. All right, next, please. Okay, so these are some of the activities or workshops, technical talks, and all that we have done over the last, for some period of time, especially during this pandemic time, yeah? So we have mentoring programs, members in transition, which we still do every Wednesday. We have YP sharing sessions, we have SPE workshops, name it, we have industrial collaboration, for example, you are in the academic line and you want to do in some industrial collaboration, you can even do that. You get distinguished lecture series. And the most fulfilling is probably community outreach, which you can actually join. All right, next, please. Okay, so the student currently you get, it's a free membership, yeah, and you get to receive mentoring, scholarships, you get to actually apply for fellowships, you get to participate in Petro Bowl competitions, student paper contests. If you ever have issues, you can even participate in, you even can get career guidance. And of course, currently, you can even join the field trips, but currently it's virtual because of the pandemic. Next, please. Okay, so currently we have a extra benefit due to the pandemic. So the fee is reduced by 50% for all Malaysians. It is free renewal membership for those who have lost their jobs. You can even get the insurance program for SPE members. Yeah, and not only that, you get to actually get yourself involved in JPT online, like you subscribe to it, and then you can actually get a lot of information to what is happening around. So all the free memberships or subsidized memberships are all actually given by Chevron. Yeah, all right, next, please. Okay, so like I've mentioned, there are 3 benefits: reduced fee, free membership renewal, and also insurance programs. Next, please. Okay, so currently SPE KL started a membership promotion, and each month there will be 2 winners. So 1 is the lucky draw for physical gifts, 2 is the opportunity to present at SPE KL activities or even events. So if I were you, I would grab the opportunity, yeah? Because the professional students that are actually transitioning from student membership to professional membership, just to let you all know, the first tier of your annual membership fee is free, yeah? Okay, from student to professional members. Next, please. Okay, so like I've summarized, student membership, professional membership, both of it, you get a lot of things that you can participate, networking, events, trainings, technical talks, career guidance. So these are all important, especially during this time. Okay, so you get free membership, yeah, insurance programs, and of course, everyone knows One Petrol, right? So especially you can get a discount for One Petrol as well. All right, so if I were you, register today and start winning. Okay, and if you stumble upon any issues with registration or membership, you can contact the email address at the bottom there, my colleague Fatima Meran. Yeah, she will be able to assist you. All right, next please. Just to give you a little of insight, yeah, we are having our new annual technical conference and exhibition coming up on 21st to 23rd of September in Dubai World Trade Center. So you have two options to attend it. One is in person, one is also virtual attendance. So you'll be able to actually get to know a lot of you'll be able to get a lot of knowledge on technical events or even viewing groundbreaking papers. Yeah, so it is a 3-day event. You can reconnect with your colleagues. You know, thanks to the pandemic, we all have, you know, gone silo. So let's get back to normalcy. Yeah, so reconnect with your colleagues, debates, collaborate on how to drive the industry forward. So this is the new event that's coming up soon, and hopefully waiting to see you all there. Next, please. All right, so SPE, we are all waiting for you. Yeah, thank you so much, everyone, and we will move on to the next agenda. Thank you.
Thank you so much, Ms. Harvin, for this amazing and insightful presentation. I think all of audience will join our SBE family. So let's now move to introduce my teammate to you. Yeah, this is Josephine from SB University of Nigeria. I am Fatma from SB Sultan Qaboos and lecturers from SB Aberdeen. Okay, let's move on. Okay, all right. So now this is the time for our speaker. Let me introduce our speaker of today is Mohammed Al Farsi. Okay, Mohammed Al Farsi is a reservoir simulation engineer working for Computer Modeling Group, CMG, in Oman, as part of the CST team, consulting, support, and training. He has taught several courses on the topic of using CMG tools for conventional and unconventional reservoir modeling with a focus of on black oil and thermal processes to companies from around the world. Mohammed graduated from the University of Tulsa in 2019 with a Bachelor's of Science in Petroleum Engineering. Now, the time is yours, Mohammed. You can share your screen if you want to.
Hello, can you confirm that you can see my screen? I'm on the presentation slide.
Yeah, we can see it, Mohammed. Go ahead.
Perfect. Hello, everyone. I hope everyone's doing well, wherever you are around the world. Good morning, good afternoon, and good evening to you. My name is Mohammed Al Farsi. I am a reservoir simulation engineer working for CMG. A little over a year now. I've had the opportunity to teach multiple courses to companies in Africa and the Middle East. Worked on some projects in black oil and thermal processes. And here today, I will be with you here today to present about reservoir simulation. And of course, we'll be using CMG. Okay, so I'd like to start by defining what reservoir simulation is. I want to know what we're talking about, and then what's the importance of it, and then we're going to get to how are we going to do this process or activity. So what is reservoir simulation? Reservoir simulation is an area under reservoir engineering that combines physics, mathematics, and computer programming to construct a reservoir model that allows us to analyze and predict the future fluid behavior as well as the reservoir behavior over time. Okay, and why do we need to do that? Because the ultimate goal of reservoir simulation is predicting the behavior of fluids and reservoir in the future to then take that prediction and optimize our development and production schemes to maximize the profit out of that asset. Now, a bit of a, excuse me, a bit of a trivial slide here, what we need to perform reservoir simulation. Obviously, we would need a reservoir simulation software, but then it's important that we have the correct machine that with the right specifications, because sometimes reservoir models can get complicated, and when they do, it's hard to run them in enough time to get enough results on your everyday machine. You would need a special machine that has it's called multi-cores to be able to run that calculation for you. And then, of course, we would need input data. That would be geology properties or geological properties, fluid properties, pressure, and etc. Okay, so what are the typical stages of reservoir simulation or a reservoir simulation project? Well, first we need the data, right? We need to acquire the input data, and then we need to QC or quality check that data and make sure that it makes sense. Example, you receive data that says you have a porosity in your reservoir, or your average porosity in the reservoir is about 0.7. That's not accurate because that's too high for a regular reservoir. Even the common ones, usually it is between 2.5 to 2.7. Sorry, 0.2 to 0.25, something like that. That's the average porosity, and 0.25 is even considered high. And then after we QC the input data, we build a working reservoir model, implementing all the sections that we're going to talk about in a few seconds. Once we have a working reservoir model, then we move into calibrating that reservoir model through sensitivity analysis. So we're checking which parameter has an effect on the results coming out of the simulation and how much of an effect does that parameter has. And then based on our findings in sensitivity analysis, we try to calibrate the reservoir model to mimic the exact production that's coming out of our actual reservoir in the field. Okay, so we don't move forward until our model is mimicking the actual behavior of the reservoir. Once we have a confident history match, then we move into forecasting, discussing different schemes of production, different plans, different developments. And once we settle on a specific plan, we start talking about optimizing the production in terms of operation conditions, in terms of trying to match the operation to the limit that we have, especially if we, for example, we want to do water injection. So I start injecting. Of course, the more water I inject, the more oil I recover, but there's a specific point where that's not feasible anymore. But we have to keep in mind that the water that I'm injecting, I'm probably going to circulate, so I'm going to produce it back. And then do I have enough facilities on top or on the surface to process that reproduced water? Okay, so that comes into the optimization process. Now, let's talk a little bit about computer modeling group, also known as CMG, and what our history and what we do exactly. So CMG was established in 1978 as a research foundation, and then was restructured as a commercial share company in 1997. We do a lot of collaborative work, a lot of collaborative research with different universities and research groups around the world. And while our popular image is in research and software, our real business is assisting all companies around the world with managing and exploiting their assets. We have been the leading and distributor of dynamic reservoir and production technologies for over 20 years now. We perform specialized consulting services, of course, and support to help our clients achieve their goals, as well as customized training. Those can be online, which we've been heavily relying on lately, just because of the crazy times that we're living in right now, as well as in-person training sessions. Our products and services are very high or add very high value, as they are typically coming back with high returns. CMG provides practical solutions for modeling oil and gas reservoirs, conventional, unconventional, but we are very well known for our EOR and advanced processes. These can be unconventionals, like I mentioned, tight reservoirs, shale oil and gas, And then we have compositionals like CO2 and N2 injection, thermal, steam, etc. Chemical that comes to like polymer, surfactant, geochemistry even, and integrated reservoir and production systems model. Okay. So as I said, our specialty is in unconventional reserves. And so this is a bit of an outdated slide here, but I'm sure that the numbers are going up since we're taking or consuming our conventional resources. So our specialty lies within the unconventional resources like extra heavy oils, oil sands and bitumen and other processes like the chemical ones I've mentioned. Basically, we have mainly 3 simulators. IMEX is the black oil simulator, and that one can handle the conventionals very well, excellently, if I may say. And the other 2 are GEM and STARS. We'll get into briefly in a second. And those are the ones that are taking care of these unconventional processes. So a bit of an introduction on the softwares and the workflow in general. So let's start with Builder. If you see my mouse here. So Builder is your graphical user interface that's used to build the data set. Greatly simplifies the process of creating a data set, as we will see in the demo, by providing an intuitive interface with various wizards and also identifying physical and non-physical data. So if I went and entered some random value in, for example, a permeability table, a relative permeability table, it will immediately identify it and then tell you that, okay, this does not make sense, you might need to change it. After Builder, which, like I said, is a preprocessor, we use it to build the models. We usually take the model and run it in IMEX, GEM, or STAR. So IMEX black oil simulator using pressure versus different fluid properties to determine phase equilibrium. GEM is your general equation of state model, or as we call a compositional simulator, which uses the EOS from Peng and Robinson's to determine phase equilibriums and model processes like CO2 injection, which is a heavily discussed topic these days. And then finally STARS, which uses the K value to determine phase equilibrium. And basically, if I can define K value very simply, I would say it's a percentage of partitioning of a specific component to another component in the reservoir environment. Okay, so you would build the model through Builder. And then in the model, there's a section regarding PVT. So if you had lab data, you would use WinProp to build a PVT model or a fluid model, and then throw it in Builder and use that integrated or kind of gathered model to run your simulation in IMEX, GEM, or STARS, and then we visualize it in results. If you didn't have lab data, then there is a quick wizard, if I may say, that we can input a minimum of 5 information, 5 different information about the reservoir fluid, and it will generate a simple PVT for us to use in the model using correlations. So this is typically the regular approach to simulating a model, but then there comes CMOST, which is an integrated analysis and optimization tool. CMOST can help you in, just think of it as your personal assistant. Because like I said, the stages of a project is you build a model, you do sensitivity analysis, you history match it, forecast it, and then optimize it, right? So you can do these individually for different, because when you're going to do these, you're doing it for different cases, you might end up with hundreds of models. So instead of doing these manually, you can use CMOST, give it the instruction, and then just watch it blazingly and amazingly do the entire work for you. Of course, you'll have to make a decision and understand the data eventually, but it will make the cases for you, it will run them for you, and basically make your life much more easier. And here we just want to show a conventional reservoir life cycle. So as we know, the primary recovery duration is the highest. After that, we might go to vertical infills just to increase that a little bit under secondary recovery. And then also pressure maintenance using gas or water comes under secondary recovery. And that can bump up the production in the later lives of the reservoir. And then after that, typically people go, or the companies go to tertiary recovery using thermochemical, and different complicated processes. We like to say, or we like to have the understanding of that in your primary recovery period, if you implement any of these secondary recovery or tertiary recovery methods earlier, then of course we're going to increase the recovery early on in the life cycle of the reservoir rather than at the end. But of course, that depends on a lot of factors like the price of the oil, the price of the process, and the feasibility of both of them together, if we can do it or not. So if it can be done, that would be the absolute optimum decision. But of course, different factors play into that. And then just generally want to tell you what are the enhanced oil recovery methods that have been done recently or throughout the time, and which simulator do they associate with. So like anything related to temperature, hot water, steam flood, CSS or cycling steam simulation, SAGD, and in situ combustion can be done in STAR because it handles the thermal calculations very well. In addition to it being able to handle reactions in the reservoir system. So if you wanted to do, like we mentioned, chemical recovery, polymer, surfactant, and alkaline, you would use STARS for that as well as GEM. GEM is excellent in the chemical processes as well, but it doesn't have as much capability when it comes to thermal processes. So with GEM, you can do CO2 injection into rich gas, dry gas, low salinity water injection, geochemistry processes that come with complicated CO2 injection in aquifers or saline aquifers. As for IMEX, you can handle immiscible CO2s, immiscible N2, and miscible LPGs. IMEX basically, like we said, it's a black oil simulator. So you have an environment or a reservoir of water, oil, and gas. And these three phases typically do not mix in IMEX. So it treats them as specific or individual phases. Whereas in STARS and GEM, because we have the option to have reactions and partitioning between different phases, then we have oil components, we have gas components, we have water components. So a bit more comprehensive. Okay, now we're going to talk about Builder. And as I bring the topic of Builder, I'll mention the features of it, but mainly I want to focus also at the main reservoir sections that each model should have. Okay, so starting with Builder's feature, Builder allows you to build a model for black oil, compositional, and thermal simulators. And if you needed to change a model from black oil setup to thermal or compositional, then you can also use Builder to convert your model from IMEX to GEM or STARS, giving you a lot of flexibility. Additionally, it has windows and sections for all the different parts of the reservoir that you need to build. So we're going to start with the reservoir section. In the reservoir section, we consider all the aspects related to the geological data and reservoir properties. We consider the tops, depth, number of layers, and faults if you have them. Reservoir properties, those are going to be under properties like porosity, permeability, and water distribution. This window over here, we're going to see in the demo in a little bit, but just want to say that you can see that we have different sections here: IO control, reservoir components, drug and fluid, initial conditions, numerical, geomechanics, and loads of recovery. Okay, so these are different components or different sections that you need to fill in to have a complete reservoir model, excluding numerical and geomechanics. We typically don't need to do much to the numerical section, especially in black oil models. In complex processes, we might have to tune it a little bit to, okay, just to define numerical section is where we go to set up certain commands to help the simulator achieve the right convergence of values and achieve the right solution, as well as increase the runtime. But in IMEX, IMEX is tuned and set up in a very nice way that we don't have to mingle with or tinker with the numerical setups a lot. So excluding numericals and geomechanics, you would have to fill in the IO control, reservoir section, components, etc., until the welds are current. Okay. Different types of grid blocks that can shape your reservoir structure are Cartesian, corner point gridding, quick pattern grid, and radial. Just a quick summary of all of these. So typically people use the Cartesian when they're building a box model and they want to test certain effects on reservoir. For corner point gridding, these will be the ones that we're mostly using because they give different, they give the structure of the reservoir in a more or better resolution than the rest. Quick pattern grid is related to the Cartesian. It's just an option that is in Builder that allows you to, for example, if you wanted to build a 5-spot pattern grid, you can go to quick grid, select an option, and immediately you'll have that grid set up rather than going and building it using the Cartesian option by yourself from scratch. And then radial cylinder coordinate system, which is typically I see this being used in well testing applications. Okay. Additionally, you can create your grid based on different types of maps like scattered data points, contour maps of 2D surfaces, mesh maps of 2D surfaces. You can import them into Builder and then put a grid on top of them and then populate that grid with the properties or the geological properties of that reservoir. Personally, I see that this is not the practice for reservoir engineers at the moment, meaning not that we don't deal with it anymore, but it's more related to the geologists part, as what the current workflow is happening, or what I'm experiencing at least, is that we receive a ready model, a static model from the geologist, and then we start working on it. We don't work with the maps and try to generate the model that way. Okay, but the option is there if that's something you needed to do. And then Builder, reservoir fluid component section, and I'll just speed up a little bit because of the time. So like we said, if we have laboratory results, we use WinProp. If we don't, then we use correlations into Builder's PVT wizard, and then generate that fluid model. Okay. Additionally, we have the rock permeability curves and different phenomena that we can model. We can have different rock types. And when I say rock types, I mean phase sheets with different relative permeability. So you can have multiple ones in the same reservoir. You can add capillary pressures to that, change the wettability, add hysteresis or interpolation between curves based on pressure or composition, depending on what the process is that you're modeling. You can have adsorption, for example, if you're dealing with polymer, then you can have polymer adsorbing to the pore volumes and reducing your permeability. And you can also have or adjust your rel perm curves using endpoint scaling. And then the initial section or initial conditions is where we set up the initialization parameters for the model. So you can have multiple water, oil, and gas oil contacts and PVT regions. Bubble points are defined either as a constant array or tables, so they vary with depth. You can initialize with gas cap and residual oil saturation. And initialization is different from PVT regions. So you can have different fluids in the same reservoir, and you can have different initialization regions in the same reservoir. So depending on what you're trying to achieve. And lastly, of course, we would need wells, and that's the most dynamic part of the reservoir. We would need well trajectories to define the wells in the reservoir model. And those wells would need perforations, as that's kind of the intersection or the access of the well to the reservoir. So it translates through perforations. Additionally, we can read data from external softwares. We can read data from external softwares, production data, I mean, and there are various commands or constraints, as we call them, for operating these wells. So lots of flexibility on that side. Okay, I tried to keep this as brief as possible just so we have enough time for the demo and the analysis. So now we're going to move to Builder to quickly build a reservoir model. So this is Launcher, our desktop. Okay, I think I need to share one more time. Okay, can someone confirm to me that you see a window with a bunch of applications?
Yes.
Yeah, Mohammed, we can see it.
Okay, so this window with a bunch of applications is basically Launcher, and it's our platform or the technology that we use to interact with the different softwares that we have. So I won't just talk about this much further for the sake of time. So we'll go into Builder straight away. So I double click on Builder. Okay, I'll be faced with a blank page, so I need to open a new project. And then immediately I get the option to select what type of model I'm trying to build. So we're going to build a black oil IMEX using SI units and a single porosity type of reservoir model. So we don't have natural fracture in this one. I'm going to set the date, the starting date of this model to 2003. And this would be, it's important to define this at the right date, as it might conflict with some production data if you're trying to import that. Okay, now this is just confirming, and you click OK. Perfect. So a white page, we have absolutely nothing. So first thing we're going to do, as you mentioned, we're going to import a rescue model, which is a static reservoir model that is handed over by a geologist typically. So to do that, we're going to go to Files, import from another file, rescue ML, and then my which is right here. Okay. It's just confirming, giving me information about when and how this file was created. So let's see, okay. We'll keep the default options here, okay. And we'll immediately see that we have a reservoir model on the first page. This window here is showing the properties in that rescue model I just imported and the properties in CMG's builder. So which do they kind of match with? So in this case, both have the same name, so they're matching perfectly. But in case they were not matching with the ones over here, there are different ways to import them by adding a custom property or just, yeah, you can add a custom property and link it to it so that you can view it in the model viewer. So I click OK. And if I open this window here, we can see different properties that we have in the model. So we have permeability, horizontal permeability in I and J directions. We have porosity. Let's see what else is in the model. Well, that's pretty much it, except for null blocks. So we see remember we saw on the PowerPoints that this section here has green ticks. So that means you fulfill the minimum amount of information needed for any model. If it's not, then we have to insert that minimum amount of information. In the reservoir section, that would be your porosity and your permeabilities, as well as some compressibility, rock compressibility value, and reference pressure for that value. So right now we see that we don't have vertical permeability. So we're going to add that by going to specify property, just locate permeability K in the K direction. And here, typically, from what I see, people usually take the vertical permeability as 10% of the horizontal permeability. So I'll do that here by right-clicking on the whole grid section, click on equals I, and then the star option, and then just put 0.1, so it's 10%. Click OK, OK, OK. So now we have it. Now we'll go and add in the compressibility values with its reference pressure. So that's over here. I don't want you to worry about the values. Those are, like I mentioned, different tests are done to acquire these data. This is a course from for one of the courses that we give at CMG. We already have that data sorted out, so I'm just going to use it, but I don't want you to be confused as to what is the source of this data. So for compressibility, I'm going to use 7.25 e to the minus 6. For reference pressure, that would be 20,000 kPa. Click OK. Now you see we have a tick mark. That means we're good. I don't need to add anything else to the reservoir model unless it was something I desired to add. If I click on any grid, you'll see the property. You'll see the address of the grid, so 561 from I, J, K. And then the property that's in display, you'll see that it's valid. Okay. If I go to the components section, double click on model, launch the black oil wizard. And then we mentioned that we need a number of 5 minimum information. Those will be the reservoir temperature, so 50, the maximum pressure that the model might reach to. So we need the data or the fluid at such pressures. So that would be 55 in this case. We're going to use a bubble point pressure calculation. No, we're not going to use generate from GR option. Just going to stick to use the value provided, which will be 10,000. For stock tank oil density, we're going to use the API option and enter it as an API oil density. For gas density, we're going to use the option of air equals 1. So that's the amount of information we need. So if you click OK, and you'll notice that immediately I have a table here with different pressures and different properties of solution for oil formation, gas expansion at each pressure. Okay, I'm just going to remove the compressibility here and put a constant value of what was the value? 5e minus 0.6. Click OK. Okay. Now the rock fluid section. If I double click on rock fluid types, this window, rock types, which we can set the relative permeability curves for the reservoir rocks, reservoir in general. So we're going to create a new rock type. And I'm going to exclude the capillary values here. So you have 2 options. Typically, there will be lab tests conducted on pores, special pore analysis that will extract these relative permeability values, and you can use. Otherwise, you can just generate tables using pore correlations by inputting the endpoints for each of these data or each of these points, which are also defined on the relative permeability plots on the right side, so you know which point, where which point is located and what does it mean. So you can either do this or input the data from a table, which we're going to do here. So just have a water oil table and liquid gas table. I'll just copy the values and put them in the table here. It's for water oil. Hit apply, and then I need to change this to liquid gas table. Again, remove the capillary pressure. And in the liquid gas table, so here we have liquid saturation, right? With gas relative permeability and then oil to gas relative permeability. There's an option here that says gas saturation. So we didn't have a table with gas saturation, but immediately they would do the calculations and set the table for you out of those 2 tables. Okay, so apply, okay, and that part is done. I lost track of time. I just need to know how much time I have. We'll continue. Please, Fatima, let me know when we're 40 minutes in. So I know if I need to slow down or speed up. Okay, thank you so much. Initial conditions, and this is where we decide our initialization setting. So we're going to go to initial conditions. We're going to select to initialize with only water and oil, so we don't have free gas. For pressure, I'm going to initialize at 20,000 kilopascals. That is 20,000. My reference depth for that reference pressure would be 1605 meters. My depth of water oil contact is 1750 meters. And then I'm going to set the bubble point as constant throughout the reservoir at 9,000. Okay, so this is the minimum information that we need to put in. Bye. Okay. Now we can start initializing the model. So typically when we try to history match a model, there are two stages to history matching. One, we need to match the volumes. So the geologist from his static model will generate volumes in the reservoir. And then whatever we do when we get the model from the geologist, we create it as a dynamic model at this point. So we need to match the volumes in the dynamic model with the static model. In Builder, we can do that easily through clicking on the IMX icon here. Say yes. It's going to ask to save. Just give it a name quickly. Okay. I'm going to save it in solution. Save. Okay. We're going to run to view initialization. Not run normal immediately, but to view initialization. Okay, run is done. And I immediately see total oil in places this much, total water in places this much, and total gas in place. So here we know our stored water in place and gas in place. Okay. Now the last part that is left for us is the well and return section. So quickly, we're just going to import the well trajectories. Okay, I'll do it from here. So I can click on this arrow here, and they go to well trajectories option, and click on well trajectories. The one I have is in table format, and you can input the units of that of the trajectories, or you can just look for the trajectories, read them in, and the units will be read automatically. Click on next to list the wells that I have in the model. Click on next one more time. It's going to tell you if certain wells are attached to certain wells. Finish, and now we're done. Next, after trajectories, we need to import perforation data. So we go to I believe trajectory perforation interval. I go to read file. Okay. Right files, SB workshop, required data, and IMX perforations. Click on it, and these are all just text files. So they're basically a text file with rows and columns with data that we need to input for the well. So they're nothing complicated. Except for the rescue. The rescue is binary, so you cannot view it without that proprietary software. Click apply and okay. Okay, perforation is done. Now we need constraints or well events, actions. What is the well operating? So to do that, we're going to select this time import production injection data. Click on this, we'll keep it as general, and then browse for that production data, usually in PRD format. And again, if I am to take a look at this text file, okay. See, it's basically a table with well name, dates of that data, and then just the rates of oil, water, and gas per date. You see that I have this for every well that's on the model. Okay, so nothing complicated. So read it in. and click next. Here we just follow the instructions on the window. So here it's asking to highlight the first line with the actual data, and then highlight the first line with the actual wealth. Click on next, sort them out to the different columns. Next one more time. Now, sometimes it would identify what each column means, but if it does not, it's going to put ignore column, and then it's up to us to help it identify that. So for the first one here, I'll set it to well group name. It knows the date, so that's good. For oil, I'm going to set it to oil produced. For water, as water produced, I don't have any injector in these, so they're all just fluid that's produced, gas produced here. The last one is empty, so he can next. Now in here it will set the constraints to oil, but we don't want to do that since the first thing after we set our model is to look for a history match. Now, when we history match, some people mix these things up, but it's important to understand that the first thing that you need to match regarding liquids is the liquid rate, not individual oil rate, not individual water rate, but the liquid rate. Because if you match the liquid rate, then you're matching the amount of fluid that's coming out of the reservoir. Now, when it comes to the water-oil ratio or water cut and percentage of oil in that fluid, we can try to fix that afterwards. But first, I need to get the exact or a close match to what is being produced from the reservoir. Okay, so we're going to change this to liquid rate. Click on primary constraint to highlight all. Right click and select liquid produced. Okay, now we are done. And just one thing here, we need to change this to do not limit. So it records all the data. This is related just to the output file, which contains the simulation results in text format. Typically, we set a limit to that because the output files can get really large in size in gigabytes. But in this case, the model is fairly simple and is not running for a long period of time. Yeah, that's not too bad. So we can set it to do not limit read output. Okay, close. You'll see that we still have an exclamation mark here. This is just related to the averaging of that reservoir production data. So I'm just going to go to average production data, right click on the x-axis, and then make sure it resets it to all intervals every month. So you have options to set it to every 2 months, 3 months, 4 months, etc. I'm going to reset it to every month, just as the original data. Let's see, it has a tick mark. It does not. So what we do on these dates window is that the last date, or if I wanted to stop my simulation at a specific date, say 2019, April 1st, I wanted to stop here and I don't want to continue simulating for the rest of the period, I can just check the box. It will put this tick mark there. And in the text file, because when we're building a data set, it's in a text file form, it's an ASCII text. So if I go to the text file and I look for that date, I'll immediately find after that specific date that there's a stop keyword. Okay, so this is what's that doing. I'll remove it from here and I'll put it at the last date, close the window, save the model one more time, and click on IMAX. Yes, and this time we're going to run the model immediately. Okay, this might take a couple of seconds. How are we doing on time, Fatma?
Yeah, we can hurry up a little bit.
Okay. This is not going to take a few seconds. So if I can explain what we're seeing here. So the first number here is the number of time steps that we're taking, and then the next column is size of days. So in each time step that's being simulated, what is the number of days or the size of days in that time step? And then in here, these are on the numerical side for Newton iterations and times of cuts. We also see days and dates, and then we have the rates of each phase that's being produced. Nothing in injection, which confirms that we're not injecting anything in this model. And then total average pressure changes, material balance error. We typically focus on this to understand if there is a problem with the data in the model. And then you have changes or max changes in saturation pressure in the reservoir. Okay, so it ran in about 50 seconds, 45 seconds. From here, if I click on launch results, if you remember, it was our visualization tool. Okay. Okay, so if I go and read, oh, I didn't read this one. So I need to do it from this link to another version that I was testing. I don't want to use that version, so I have to go to launcher, pick up the model, whether it's .dat, that's the one representing the model, or SR3, pick it up and throw those results. Master tag table, which means that the model has an issue in running, but let's check and see what's going on exactly. Oh, okay, it did not register the run of the model. Well, not to waste time, I already have one that's been done. We just thrown this into IMAX and it produced SR3. So if I pick up SR3 and put it into results, okay. In here, so this is the model that we just ran. And if you wanted to see, let's say, so we have templates pre-enabled in results. These templates are the ones that go into immediately or automatically plot these types of plot for you for each of the wells. Okay, so if I wanted to see, for example, oil rate in all of the wells. So I can see, for example, here oil 1. If I switch to plot group, I can see the rate for all of the wells. I need to go to plot group and then switch between different pages. Okay, but let me read in the historical data. So our data, read in, go. Here, yeah, open. Okay. Let's take a look at, let me resort them. So then let's take a look at each one of them. So let's see, for well 1, my simulation is under predicting the oil production. For well 2, for oil that is, and then for water, it's over predicting it. So the circles here is the historical data that's gotten from the reservoir, from the actual reservoir. And then the solid lines is what the simulator is giving to us. So typically at this time, we would go and try to tinker with the values a little bit. Let's see liquid rate. Let's see liquid rate. For liquid rate, okay, it's close. It's close. It can do a little bit of work in this area, but it's close. So maybe a little bit of adjustments on pressure in the reservoir, a little bit of adjustments on permeability and relative permeability specifically to get the right rates for oil and water would help with that. Another thing I want to show you in results, and that's a nice feature that you can use. So, you know, instead of getting plots and putting different things in a PowerPoint, which you can do by an option here to export to PowerPoint, you can, for example, look at the model in 3D, right? And this one would have all the information that's coming out of the simulation. For example, if I wanted to see pressure and I animate the model, I'll see the pressure changes around the reservoir as I'm producing. So from the color scale, I understand that this area is getting to around the 16,000. kPa, and some are even lower. I wanted to show you that if I select one well, for example, let's say well 14 here, right click on it, I go to reducer, almost there, guys. I'll immediately see what the well is producing, the rates, with the model itself next to it. So if I animate, I can also see where the line is going at that specific date. I see what's going on in the reservoir. I can switch to different wells just simply by clicking. So I think it results gives a better option when it comes to presenting your data. How much time do I have, Fatima?
So it remains almost 1 hour from our workshop. So yeah, you can continue for 10 minutes maybe or more.
I can do some analysis, but I think we're clocked out, yeah?
Yeah, it's okay.
Okay. Well, the next step after this, because we just built the model and it's working, will be comparing the historical data with the behavior of the model from the simulators that we received, and then just tuning the model a little bit to match that data so we can be confident in the model and forecast from it the future of our actual reservoir. With that, I guess I'll stop with the demo and we can move to the questions session.
Okay, thank you, Mr. Mohammed, for this insightful presentation and amazing demo. I hope all of us, all of the audience have enjoyed this session. Now let's move on with the questions and answer session. So please, if you have any questions, you can type them out in the chat box, or you can open or turn on your microphone to ask the speaker directly. So if you want to turn on your microphone, you have to raise your hand using the raise hand feature in the Zoom. And so far we have got good questions from some of the students. Okay, let's move on. The first questions from Sarba, from a student at IIITM. Can we account for fault reactivation in simulation models?
Absolutely. You can put geological fault units in your reservoir model. And with that, there are two ways to do that. You can use a physical fault structure to set up over there, or you can use a transmissibility option that we also have. So you define a specific transmissibility somewhere in your reservoir, and then that transmissibility would have a value of 1 for full flow or regular flow. You can tone it down for reduced flow, or even tone it up to increase flow.
Good. I hope you got the answer, Sabra. Let's move on with the next questions from Raj Kumar from SPE IIT ISM. When we set for the total liquid produced instead for the oil produced or water or gas produced, considering we are doing history matching, you highlighted that we can fix the water production later, but in case we history match for the total production, but the water production in this well is really high, so wouldn't it affect the economics?
Yes, that would, but it's high because of, well, first of all, in all the courses, I like to say that these are training models. So we're just showcasing the workflow, showcasing typical behavior, typical results that you can get. If this model was actual and the water rate that we saw was real, then depending on what the model is producing, how much oil is producing, depending on the economics themselves of the model itself or the actual reservoir, then that would affect, of course. But in our case, as you saw, the reservoir simulation was over, I believe, over predicting the water, yes. And so typically we would go back, adjust the relative permeability of the water a little bit, add some maybe permeability modifications to the model to tone it down and get it close to the historical data. You're very welcome.
All right, so let's move on. I hope you get the answer, Raj Kumar. So there is a question, okay, from Hazik. Could you explain further on the CMOS model? How does that interact with the simulation? And does it employ any AI or machine learning models?
Okay. So, like I mentioned, consider it as an assisting tool that uses AI intelligence to, okay, this is how I'll explain it. So you have a model, okay? You have not touched it. You have not did any sensitivity. You have not done any history matching. You have a working model. You can take it and put it in CMOS, and there's a specific workflow for that. There's a bunch of courses on our website. If you're interested, you can have a look at them. But you would take the model to CMOS. There are certain, immediately when you get a model, there are certain parameters that are running in your head. You're thinking, okay, this might affect this model somehow. This might increase production, reduce production, mess with the pressure, etc. So you define these parameters to CMOS, and then CMOS, what it's going to do is create multiple data sets rather than you creating them manually. CMOS will create multiple data sets based on specific ranges of values that you assign for these parameters. Then it's going to run them and show you the sensitivity analysis of the model, the sensitivity of the model to these parameters. From there, you can move to another step that comes after it, which is history matching. So you use an objective function, as we call it. In this case, in the history match, we call minimizing error between the history match data and the historical data. Okay, sorry, from between the simulated data and the historical data. So we try to cut the gap or reduce the gap between the two plots to reach an acceptable match. From there, it's just a continuing workflow where you take these parameters. Well, in forecast, it's not about parameters anymore, but it's about operating conditions. So you would use the operating conditions as parameters that CMOS would adjust to find, maybe trying to find the highest net present value in the model. Okay, so you try to do that and optimize the model based on the highest NPV. Something I didn't mention as well is uncertainty analysis. So typically after optimization, you would start going into the uncertainty analysis and assess the possibilities of your model having specific geological realizations, because when we generate first maps of porosity and permeability, those they're close. They're what we're looking at as a potential case for the actual reservoir, but they can have different realizations. So we need to take into consideration the reality that the porosity might not be the specific value, but might could be something around case where we call it P90 or something around P40 or P50. These are just levels of confidence, levels of realizations that we have.
Okay, all right. So I guess Hazik also mentioned another questions. I am wondering on compatibility with other simulators. Let's say there is an effort to convert from some other simulator. Example, SLIPS or TNAV to CMG. Is there any models that assist with that, or we would need to rebuild model from scratch?
So typically when clients reach to us, they would have models that they built using other softwares previously. So we have a software called Data Importer. We have a program called Data Importer that you'd pick any data set, and this is related to Eclipse. So if you take any Eclipse data set from E100, the Blackwell data set, and you drop it into the Data Importer, it will immediately transform it into a CMG format. And now we've improved IMAX so much that you don't have to use the Data Importer sometimes. You just take the data set and run it into IMAX, and IMAX will make the conversion. As for more complex data sets, typically clients reach out to the support team, to us, and we handle the conversion, matching the data, and then we deliver the rest back to them.
All right, so next question is from Sabra. He said, is there any collaborative space within CMG, similar to how Petrol Slips has their studio collaborative space within the simulation software that allows multiple people to work on one project?
Yes, I might have not mentioned the integrated system of software that we have. Just because of time, and I wanted to focus on Builder and the simulators. But as mentioned, we have an integrated surface for production facilities and reservoir model. So they're both of these sections are coupled into a software called Coflow. And this software is database software. So when you use it, it's like sitting in a network where a dozen of different people are working on the same project of different aspects. So one person could be working on a project in the same project at the same time, could be working on a geological realization. Another one could be optimizing production. Another one could be trying to, modify the properties of the reservoir. So all of them are acting at the same time in a specific format that everything is traced and all the connection between them is continued. And if you'd like to know,
let's have the last.
Yeah, I was just going to say.
Hazik, if you have any questions, you can turn on your microphone.
Okay. Questions?
So, all right, okay. Okay, from Hazik again, can you comment on the speed of the solver of CMG versus other conventional simulators? Can we expect certain advantages over those?
What I can tell you, and these are findings from our certain clients do some testing and they share their results with us. CMG, IMAX especially, the Blackwell simulators proved to be faster than a lot of other simulators, and it's getting better and better every year, especially with the auto-tune technology that we use in it that tunes the numerical aspects, the solver options that you just mentioned, into enhancing the speed of the simulation or reducing the runtime.
Okay, all right. So I hope the questions has been answered and you get the answer, Hazik. So last question from Raj Kumar. So given that the data from Wolf field has been made public, so as a beginner, to what extent can we utilize the data to do any analysis in Excel and understand the field?
So is the question, can they use the results to analyze in Excel?
So I don't know if this is in our workshop because.
Okay, are you saying it's not related to our workshop? Well, in general, if you wanted to use Excel to make analysis and plots on the results of the simulation, then you can absolutely do that. As I've shown, there's an option in results, the software, to export to PowerPoint. There's also an option to export several data, like well data or reservoir data, whatever that's coming out of the simulation, into Excel as tables. So you can definitely utilize Excel in that way.
Okay, I think I don't want to like have more time on questions because we already passed. From Abdullah Al-Badawi, he said, with the rise of CCS, carbon capture sequestration studies, is there any chance to start simulating it using CMG?
Oh, we have already started. A lot of projects are using CMG and GEM specifically on simulating CCS operations. Yeah, a lot of in the coming versions, we're going to have a bunch of options regarding to that, hopefully as well. So it's not a matter, or it's not a question of if we can. It's a question of how do you want to do it.
Okay, so that's it for the questions and answer. If you have any questions you want to ask the speaker, we already attached his LinkedIn account and also his email. You can reach out to him. And now we have to move on with the Kahoot game. So enjoy your time. I guess there's kind of questions related to this simulation showcase workshop. So yeah. Magdalene, time is yours, so you can start. Or Josephine, yeah. You are muted, Josephine.
Hi everyone. I think Josephine might be having technical problems, so I'll just share the game. Can you guys see my screen?
Yes.
All right. So, I'm sure many of you are familiar with Kahoot. Yeah, people are already joining in. Okay, we will wait for.
Majduline, we cannot hear the sound.
Yeah, I have turned it off for now. Yeah, but. guess we're gonna start now. I'm gonna start now, and you can still join later because the code is going to be displaying. All right, so I'll start now, and don't worry if we start and you haven't joined yet. Okay. Starting in 3, 2, 1. Right. Let's see how many people got it right. We have 4 people got it right. And yeah, the right answer is in blue, a methodology where machines are used to solve numerical reservoir models. Let's see who is topping. Yep, we have Mahidin. Okay, next question.
Can you read the question? I can see.
Yep, and it is true. We have 10 people having all the answers correct. The answers correctly and only 1. Let's see who is topping the leaderboard. Oh, Mahidin is still on top. And yep, let's go to the next question. All right, we have the answer is true and 4 people got it right. Can you guys see the questions? Because I think when I maximize my screen, can you see the questions?
No, actually, I wasn't able to see.
I'm sorry,
This way
my
is-
I
bad.
was not able to see any of the questions.
Okay, how about now? Can you see it?
Now we can see. Yeah, this is better.
All right, my bad, guys. Okay, so sorry if I made you like lose some points. So the answer is true. And let's see who's topping the leaderboard. Okay, still have Mahidin on top. Good job. Next question. All right, so the answer is true as well. And whoa, 5 people got it. Okay. Mahidin topping the list. It's water flooding. And it's blue. Let's see who is topping the list. Oh, okay. Next question. Right, the right answer is it is an integrated effort, and it's only 1 person got it right. Hard luck, guys. Okay. Oh no. Right, we have still Mahidin on top. Is anyone facing any problems? Because I feel like only 5 people are playing. Is there like any problem?
Actually, I'm not the screen.
You still can't see my screen?
Actually, my it says
Oh, there was lag. I'm so sorry, guys. Internet. Okay. Next question. It is true that you can convert black hole model to EOS model. So 7 people got it right. And yeah, so we still have Mahedin on top. We have 2 more questions. You can still do it. Yep, the answer is all of the above. 6 people got it right. Yeah. So we have 2 more questions. This is question 9. And it is true. We have 5 people who got it correctly. Whoa, Mahedin is on a roll. And yeah, last question. That's 8. That's the last question. Let's see. We have Indra. And great job, guys. And the technical issues that happened. Okay, back to you, Fatima.
Congratulations to all of you guys. It was quite a bit hard, maybe due to the technical issues. Now, let's move on to the photo sessions for memory. Please, I encourage all of you to switch on your video so we can take a photo of all of us. You can use this virtual background. Already have been sent in the chat box. So, yeah. Smile. Good. Thank all of you. Nice to see you all. This is the first time to see the team as well as you. So welcome. Okay, great. So I guess we have finished this session. We move on to the last part of our workshop. So to close our closing remarks, close the workshop. Sorry, before that, we need to send to you the feedback form so you can fill up the feedback from the link provided to you in the meeting chat box or by scanning the following QR code in order to get your certificate of participation emailed to you. So you can scan this QR, it will take you directly to the form. Or you can use the link that being shared in the chat box, yeah. So yeah, you can ask any questions or you can evaluate this session, the workshop, speaker, as well as you will get a certificate of participation. So yeah, let's move on to just close it. Just to remind you that next Saturday we will have to continue our program of Saturday for SPE. We will have amazing and interesting workshops and talks. So stay tuned and you can register using the link that will be provided to you also in the chat box. So yeah. Okay, just to close the workshop, I'd like to thank our speaker for today, Mr. Mohammed Al Farsi, sorry, and also our attendees from all of the chapters. Nice to see you all, and this is an honor to be with you. And thank also to the organizer, Asia Pacific University SPE Student Chapter and Kuala Lumpur Section Young Professional, and all the collaboration chapters from around the world. Thank you so much, and yeah, we will wait your feedback. If you have anything to add, Mr. Mohammed, you can do that.
No, nothing much. Just thank you for the opportunity. It was great, and I hope we were able to share the knowledge with you regarding reservoir simulation, even if in that short period, which was a little tough because there's a lot of information that must be conveyed to understand the whole process and the whole workflow. But I hope we were able to deliver the main objective and the main idea of the presentation.
Yeah. Thank you so much, Mohammed. Thank you, all of you guys, and see you, inshallah, next Saturday, and as well as see you next talk later on. To see you all there. It's about petroleum economics. And enjoy your time. Bye.
Yeah, thank you.
Thank you, everyone.
Thank you.
Thank you, Fatima. Thank you, Mr. Mohammed. Great session.
Yeah, thanks.
Thank you, Fatih.